So let's extend this idea of rings and circulations being put down by the jet stream. In the tropics, we said it's warm, it's low pressure, a lot of rising air. ITCZ is straddling the whole tropical belt. Every time you have convection, which means rising air and convergence, you have the possibility of rotating air, right? So it's as if convection, the rising air, the rainfall, cloud formation, is always putting down seeds for hurricanes, or cyclones is the more general term, and typhoons in the Pacific is the specific name. So these are low pressure cells. So now you have to imagine your feedbacks. What feedbacks can happen? You have very warm air and you have cyclonic circulation, so counterclockwise, I should be careful, and air is kind of diverging, air is converging, and there is rising air in the middle. That air can constantly take up energy from the ocean and expand and create condensation heating, right? So you have um, feedbacks in terms of warm water being able to evaporate more readily, and you have these little low pressure systems that are converging air into it and rising. So essentially, you are going to create conditions that are very favorable for cyclonic little low pressure cells to grow into tropical depressions, tropical storms, and this wind water vapor feedback is very important. Okay, so air rises and the condensation heating happens, demanding more moisture, more rising air, and the storm begins to develop. The low pressure begins to deepen. So the strength of the hurricane or a cyclone is always monitored by just how low the pressure is getting in the center of the cyclone. Remember, we are at 1 atmosphere at sea level, 1000 millibars. So if the pressure drops very low, then you're going to have very strong circulation around it. So the scales exist for defining what is very strong. We cannot just use descriptive terms like that in science, especially because you have to also warn people about how dangerous the cyclone is that is coming towards them. So tropical depression is when the wind in the circulation is still less than 61 kilometer per hour. In our region, we always do kilometer per hour, whereas in the US, they tend to do miles per hour. It becomes a tropical storm as soon as it crosses this barrier of 61 kilometer per hour, and a tropical storm can get up to 120 kilometer per hour. That's pretty strong winds. And then it becomes a hurricane or a tropical cyclone as it crosses 120 kilometer per hour. The low pressure, the rain, the winds together create very destructive system that comes on shore, also sweeps in the sea and brings storm surge and inundation with it. So the Saffir-Simpson scale for hurricane intensity has been in existence for many decades. So hurricanes are defined as category 1, 2, 3, 4, and 5, whereas tropical cyclones, we tend to think of tropical storm, cyclone, severe cyclone, very severe cyclone, super cyclone, and so on and so forth. The wind speeds also tend to be a little bit lower for the cyclones over the Indian Ocean, and I'll say why that is in a minute, but I think you have some idea why that is intuitively. So the associated wind speeds in kilometer per hour, 120 to 153, 154 to 177. By the time you reach category 5, the wind speeds can be greater than 250 kilometers per hour. General expected damages can range from minimal minor damage to the buildings to moderate roofs flying off and can be extensive when you reach category 3 and can become extreme and catastrophic when you reach categories 4 and 5. So when the cyclones come in and hit land, it's very critical to monitor forecasts to see at what intensity it might end up hitting the coast, and then what happens to it as it hits the coast and moves inland or veers off back into the ocean. So hurricanes, about 100 are generated worldwide. The tropical belt, as I said, is very conducive to these low pressure systems, which can grow into cyclones, hurricanes, typhoons. A total of about 100 are generated in a year, and they require ocean water. That's the energy that feeds the evaporation and the condensation, heating, and the feedback. Has to be warmer than about 25 degrees centigrade. People compute what is called a hurricane potential. You need this warm, moist air. The Coriolis effect is important because the rotation is Coriolis effect, right? So if you are very close to the equator, Coriolis is very small. Remember, on the equator is 0 and it's very small, only gets larger as you go off the equator. So very close to the equator, it's very hard to maintain rotation. So you don't get cyclones typically on the equator or close to the equator. Only when you get off by a few degrees you begin to have hurricanes, cyclones. The hurricane season over the Atlantic is typically June 1 to November 30th. So the question under global warming is the season becoming longer, starting early, ending late? Are the hurricanes increasing in number? Are they getting stronger? And so on and so forth. This is a nice figure which shows that the most dominant region of hurricane formation is in the Northwest Pacific tropical region, and these red lines are where the cyclones are forming, and they are getting stronger and going off into the South China Sea region, crossing the Philippines, or they are veering to the north, going all the way into Japan and north, and hitting land and breaking off. Why? Because remember, the energy is from the ocean. As soon as the cyclone hits the land, it doesn't have that much energy to feed on anymore. So it breaks into pieces and can go on for days and create lots of wind damage, rain damage still, because it's like a nuclear bomb going off. So it still has a lot of energy. Tropical Atlantic hurricane region is very critical. There are also cyclones in the Eastern Pacific under the ITCZ, where there is warm water. Right, intertropical convergence zone is a rain band. That's also where the warm waters are. So you can clearly see this long band of ITCZ, which is favorable for cyclones. And there are also cyclones in the southern hemisphere, as you can expect. But because of this asymmetry, again, there is a difference in the number of cyclones. And in the Indian Ocean, you can see the region over which the cyclone can travel and feed on the ocean and get stronger is much smaller. So we have the Bay of Bengal and its cyclone season, Arabian Sea and its cyclone season, and they tend to be in the pre-monsoon season and the post-monsoon season, because there are factors which make the atmospheric conditions favorable for the cyclone to grow, and the monsoon winds change too much from surface into the atmosphere, and they tend to take off the energy from the cyclone. So not many cyclones occur during the monsoon season. So they happen either before the monsoon or after the monsoon. Okay, so technically they're happening in the northeast monsoon season. Okay, that's kind of the cyclone story. There are lots of details here about the impact of global warming and so on, which we won't get into, but we will look at some specific examples of cyclones that have done a lot of damage. Unfortunately, the book is focused on the US and the hurricanes, but you can also look up information on various cyclones in the Indian Ocean, like Nuri and the 1999 cyclone in Odisha, which created hundreds of thousands of deaths. So it is a very serious problem. India is getting very good at predicting cyclones. People are getting very good at listening to the forecasts and moving when necessary and so on. So the number of deaths have been reduced greatly because of cyclones in India, but not the same in other countries in the neighborhood, which India tries to help a little bit. So that's something to keep in mind.